Part one of the story, I suppose. Right, the recreation of the pool ball experiment, where it was coming at 1.7 before, and Gary was saying, oh, that's halfway to his result of 2-to-1 ratio. Don't worry, this video isn't just me chatting shit for half an hour. I am going to show you some real world demonstrations and mix it up a bit. Try and make it reasonably interesting. That's a challenge for a boring experiment like this, I tell you. 2, 3, 4. And 1.4-to-1 ratio that the mainstream science predicts. Let's be honest, this is the only one Gary is going to be interested in watching anyway. Let me show you how this works. We start off with a blank form for each example of the experiment. So first of all, I measure how many frame counts for the lever to move before it releases the ball. God, this is real sad bastard territory, isn't it? So the first one is 17. Then I count the half ball frames. In this case, 29. Then I count the full ball frames, because that takes longer. In this case, 58. Then I go on to the next trial run, number 2. Same again. Lever speed, half ball speed, and the full ball speed. And then trial 3. Lever, half ball, full ball. Then I total them up, 55, 85, 170, divide 170 by 185 to get the ratio, and it comes out at 2-to-1. That's a verification that the experiment is working basically fine. Experiment? It just beggars belief really that we're having to call this an experiment, because we're not 11. You know, this stuff's fucking obvious. Why the hell are we having to go through this ridiculous ritual just to help this idiot understand why he's talking such bullcrap? Anybody would think he was 5. He's a grown man. If that part of the experiment doesn't come out right, or very close to right, then that means the rest of the experiment isn't much use. So then we move on to the launching the single balls, launching them one at a time. Only an imbecile would think it would still produce a 2-to-1 ratio. Sorry, I'm eating a biscuit. And once again, we first of all check how long it takes the lever to move to the release position, and now you see that because it's only having to push one ball, the full ball in this instance, the lever can move faster. Previously it took about 17 and 19 frames to launch 2 balls, and now it only takes 11 frames. It's going faster. So then the full ball takes 30 frames to reach the end point. Okay, so that's trial 1. Then we do the same for trial 2. Made a small correction there because the bar moved when it keeps getting hit. So then trial 3, same again. Then we just do the half ball on its own. Same again. Lever speed. Oh, I never total them up first, don't I? 31 and 90. So I can do the adding up after. Reach. So then we go on to the half ball. Well, I'm not going to show you what happens to the half ball yet, because you won't watch the rest of this video, will you, if I show you now? Well, yeah, the early attempts to recreate that experiment, just doing it the same way really, unsurprisingly gave pretty much the same results. So then I had to set about modifying it various ways to stop the balls skidding. But the thing is, I had to film it with just this crappy webcam. So that was hopeless. It wasn't high speed. 30 frames a second, just to get a rough idea whether it was coming out any better, before I managed to find a way of filming at 240 frames a second with an iPhone. Getting the files off the iPhone onto the computer, that was a nightmare. I eventually solved that, but they aren't compatible really with a Windows PC. So in the end I had to pay for this iMazing software to download videos off my phone, large files, and it worked brilliant because it was a pain in the ass before this. Anyway, the first few experiments I did that were coming out pretty much the same, even though they were filmed badly, it's not worth sharing even if I can find those files now. They're mixed in with all sorts of other crap footage I didn't bother titling, so it's not really worth sharing because the results were only coming out pretty much the same, 1.69, that kind of thing. I can't remember exactly. So then I moved on to quite a few more, I wouldn't say adventurous, but different variations of the experiment. And now I'm so confused because I've got so many files. I filmed the original file, then I have to convert it to MP4 to work on my Windows computer. Then I have to frame count it at 240 frames a second, the most laborious way imaginable. Just click, 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 click. It takes forever. Honestly, it takes ages. Then I have to edit out all those long periods of me click, 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 clicking 240 times, maybe 1,000 times to try and get to the point in the video I want to get to. Because if I try and fast forward it, I miss it, and then I have to go. The quickest way is just to have the patience, just keep click, click, clicking. But it's so laborious. I wouldn't want to force anybody to watch that. But that was the only way of doing an accurate frame count. But then I have to edit it, chop out all the boring parts of me trying to find each start point. Then I have to tabulate it, make a table of all the results, do the calculation, reach some conclusions, modify it again and go through the whole procedure again. And I have to also do a crude frame count at 60 frames a second. Well, I don't suppose I have to, but I tend to do that before I've done the 240 frames a second frame count, because it's so much quicker to do the 60 frames a second frame count, because there are fewer movements to count. Plus I tend to think maybe you want to check the frame counting, and you can do that more easily yourself if you watch on YouTube. If it comes out at 30 frames a second or 60 frames a second, you can do a crude frame count then and just verify that what I've done was correct. Because I do make mistakes, because 60 frames a second is what my hit film editing software, the only one I know how to use, that's the frame rate it converts 240 frames a second footage to. It won't play 240 frames a second footage. So then when I frame count, the balls are moving much more than they would when I'm clicking at 240 frames a second. So the frame count isn't as accurate, but it gives you a fair approximation whether it's supporting Gary or supporting us. Anyway, that's where I am, but I'm so lost now because I've got so many bloody files where I've edited and the editing hasn't come out right, so I edited it again. Then I end up with, when I'm looking, I'm thinking, which copy is this? You know, why is this one 11 minutes long? No, this one's 13 minutes long. This one's 7 minutes long. What's different? It takes forever. It's driving me fucking batty. Anyway, sorry for the delay, folks. I heard through the grapevine that Gary thinks the delay is because I can't get the results I want. Well, it's not the results I want. I just want the results that are true. You know, I don't really care whether if it supports Gary, it supports Gary. I don't mind sharing that, and I will do. I did shoot my mouth off a bit, like, you know, saying, "Oh, it's very easy to just prove you wrong." Never is it? These things always get more complicated. You solve one problem and you create another. Like I tried wrapping the balls in balloon rubber, like a band, so that they would have grip, so they wouldn't skid. It worked out all right, I suppose, but it wasn't necessary in the end. The simplest way to solve the skidding problem was to not roll them.
What in God's name made me think it was a good idea to do an intro to this video?
I just thought it was a nice smooth surface, so there were no bumps that could interfere with the travel of the balls. In the end, what worked out best was just rolling them on abrasive paper, just enough grip. Or better still, just make the effort to build dual air tracks, which is what I've done. Now, that will set the cat amongst the pigeons. That's interesting. Stop them from skidding. And I tried experiments where I deliberately made them skid, stop them from rotating. I've got so many that I'm so confused I can't remember the results of any. And whenever I keep thinking of uploading something, I think, well, where do I start? Do I start with something that supports Gary's case, which will annoy people because they'll say, well, that's obviously wrong, there's something wrong, you know, you've done a bad experiment, Steve, an even worse one than you did before, because this is coming out 2-to-1 ratio for the single ball launches. Or do I upload the ones that support us and come out around about 1.4? But then that's not what Gary wants to see, is it? Well, I'm not here to please Gary, I'm not here to please anybody, I'm here to just represent what I've done. You know, but I'm not a scientist, am I? I'm just an ordinary geezer with a hacksaw, basically. That's all I'm capable of doing. Very basic things. I'm not a theoretical physicist. Like Gary. I'm just here to try and do some layman's experiments and show what actually happens in the real world. But there are so many complications, so many small things that can affect the result. Like at one point I put guides on the lever, to something to cradle the ball while it leaned against the lever, so every time I did a run it would always launch from the same position, so I thought we'd get more consistent results. Now you'd never think that would backfire, would you? That's where my fucking sponges went. I've been looking for them all week. But it did. I tried reducing the size of the cradle thing, made it worse, and eventually just got rid, start again. I tried wrapping the balls in tape, because I thought, well, if I wrap the balls in like thin recording tape, like cassette tape, fix that to the table, then when the balls get pushed, they have to unwind that tape as they travel. Therefore, they cannot possibly skid. I only gave that one try and thought that has potential, but even if I get the result that we're looking for, the 1.4, Gary's going to find some excuse as to why that's invalid. And it might be invalid, I don't really know. Can't be bothered though, really, because I've done so many other experiments. How many variations am I supposed to do? Try measuring over a shorter distance, tried making the lever shorter.
The best thing about this video is that it eventually ends.
Tried making the lever even shorter still. Tried strengthening the band, tried weakening the band, tried... God, I live a sad life, don't I? Tabulating all these results as well. I'm sorry, but I'm beginning to think I'm going mad. Why does anybody give a shit about this? Why do I give a shit about it? Why am I bothering to do this ridiculous experiment? Why does it even pass as an experiment? It's not an experiment. It's just fucking common sense. Easy. Bore the shit out of people. Like you're doing now, Steve. So whatever I upload, it is what it is. Don't get upset if it isn't the result you want, folks. Gary's side and our side. That isn't to say that when I get a result that looks like it supports Gary, I believe it. I think when that happens, it's me who's done something wrong. Because the experiment to end all experiments, as far as Gary was concerned, a few years ago, when he said, this will decide the question once and for all, launching the one mass and the two mass off the edge of a table.
This experiment decides the question once and for all. Here's where they're saying it would land. 1.4. Instead of 2x, it'll only go 1.4x. This experiment decides the question once and for all.
It did prove things once and for all. Came out exactly right for us, absolutely wrong for Gary. So it did answer the question. Halving the mass cannot possibly make it go twice as fast. It can only make it go 1.4 times as fast at best. 1.414, and that's what the experiment showed. So it did decide the question once and for all.
This decides the question once and for all.
I've made the band stronger now.
So it doesn't really matter what results I get in these other experiments. Which begs the question, why I'm bothering? If they come out in favour of Gary, it's obviously wrong. You don't fucking say. Because it's not possible to simply halve the mass and make it go twice as fast. It simply isn't possible. If it looks like that's happening, that's an optical illusion or something, or it's, I don't know what. There's got to be a reason. It cannot physically happen in the real world, as we've proved with the Gary experiment. Launching off a table edge. Impossible to make the half mass go twice as fast using the same force. And we all know perfectly well that if it was possible, he would have done it, because it's so simple to do. He would have made the effort. The fact that he hasn't tells us everything we need to know. Don't bother to read this crap unless your name's Gary. One, 2, 3, 4, 5, 6, 7, 8, 9, final one. That one didn't even come out 2-1 for both balls launched together, so I didn't bother carrying on with that one. Turned out there was a bending issue with that lever that was causing all sorts of problems, so that's why I abandoned that in the end and went for a shorter lever, or more than one shorter lever. I made a short video about that separately. I don't know whether I can slot that in here or not. I'll make this video too long, perhaps. I've just double checked what I said there in case I'd remembered wrong. So I've just done a very quick, crude frame count, and it came out at 2.3 to 1 ratio, which is rubbish, isn't it, for this stage of the experiment. But I tried measuring over roughly half the distance to the end of the springs that you can see, and that came out at more like 2.2 to 1 ratio. So it improves when you measure over a shorter distance because the balls are losing speed, while the full ball turns out to be losing more speed than the other one. So then I tried measuring over a shorter distance still to the 1 inch line. Thought it was the half-inch line at first, but it's the 1 inch line. And then it comes out to more like 1.9 to 1 or 2 to 1 ratio, which is pretty much what we're looking for, isn't it? So in other words, you do have to measure over the shortest distance you possibly can. But this was recorded with a webcam though, and it was crap, so it wasn't worth pursuing any further anyway. So starting this again, measuring just 1 inch to the 1 inch line, it's 1, 2 for the half ball, and another 1, 2 for the full ball. And it's just crept past this actually, but it's closer to 2 to 1 than it was before, wasn't it? Because it's not had a chance to lose speed yet. This is a crude frame count though, but just to give you the idea that it's pointless measuring over too long a distance because the full ball loses more speed than the half ball. Let's just do a crude frame count of this. This is go 1, I think, isn't it? Yeah, oh yeah, it's go 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the half ball. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23 and a half. See, that's not right, is it? And I stopped doing 10 trials of every experiment when I eventually realised 3 is enough, more than enough. The only thing to learn from this next one is that you get a far better result measuring over a very short distance, an inch or so. 3, 4, 5, 6.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19,
20, 1, 22, 23, 24, 25, 26,
7, 8, 9, 20, 31, 2, 3, 34, 35, 6, 7, 8, 9, 40, 41, 42.
43, 44, 45, 46, 47, 47.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17,
18, 19, 21, 3, 24, 25,
6, 7, 8, 9, 30, 31, 32, 33, 34, 35, 6.
7, 38, 39, 40, 40.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.
24.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24.
4, 25.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
15, 16, 17.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
15, 16, 7, 16 and a half again. The results weren't that much different when a frame counted at 240 frames a second compared to 60 frames a second. Still came out about, 1.51 to 1 for the single ball frame count ratio and 2.29 to 1 for both balls together. So that's even worse than 2.23 that it was before. But what's interesting is, what really does make a massive difference is just measuring over about an inch or so, which I do shortly. I think I better show you that, because then the results come out good. An average of 1.93 to 1 for both balls together. One came out at 2.06 to 1, the other one came out at 1.78 to 1. Okay, a little lack of consistency there. But then again, it is quite difficult to measure over an inch. But then the single ball launches, they came out at 1.39 to 1. And I was able to measure the lever ratio, compared full ball to half ball. And the ratio there came out at 1.33. I think that was the same as the previous case, actually. Well, obviously it was, now I come to think about it. I tend to think that the lever ratio is fairly indicative of the actual launch velocity, although I'm not sure. Let's see what the frame count ratios work out to if I only measure up to the 1 inch line. See, up to this line here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 15, want it, 15. So now I'm checking for the full ball. 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 11 I think there. 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so that's 31 for the full ball. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 I'm going to say. I'm not sure. It's only an experiment. Now the full ball. 20. 1, 2, 3, 4, 5. 25 there, isn't it? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16 I think for the full ball on its own. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think 16 again, really. You can hear two voices, sorry, because I'm playing back my old recording. One moved already, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 11 for that, I think. So in my original experiment, the nub of Gary's argument was that the reason the half mass ball went at 1.7 instead of 2 times faster than the full ball was because it was at a disadvantage because it was skidding So let's see what happens when we deliberately make both balls skid so they can't rotate by placing them on a low friction little disc. Those little hubs that you used to get in cassettes, those are obviously low friction because they're designed to have low friction. So I glued the balls onto those so they couldn't rotate, they had to just skid along. So let's see which ball gets the advantage. Gary said that the half mass was at a disadvantage because it skidded. It would have gone twice as fast had it not skidded. So let's see what actually happens in practice. It would be easy to be fooled by these results because at a glance it looks like Gary's got the 2-to-1 result he wanted, 1.98 whatever, even though the 2-to-1 ratio didn't work out for the both balls at once. Okay, this will continue to a part 2 shortly.